Welcome to this quick tutorial on how to access and set up your ColorLab account. Let's get started. To begin, go to colorlab.dnaphone.it and log in. If this is your first time accessing the platform, you'll need to create a personal account. Fill in all the required fields, making sure to enter an email address that you check regularly. Once submitted, you will receive an authentication code via email to complete your first login. If you don't see the email, remember to check your spam or junk folder. The sender will be no reply at verificationemail.com. For easier access in the future, we recommend bookmarking the website. Now you're ready to start using ColorLab. This is the main page. At the top of the page, from left to right, you will find the main ColorLab tabs. Input, to import data for processing. CLab chart, to view CLab data through different types of graphs. Calculations, to access functional modules for CLab data processing. My Sessions is the archive that stores all your analysis sessions. When you first log in, you will find 2 preloaded demo sessions. The Reports section is currently under development. On the right side of the page, you will find Contact Support to reach the DnaPhone team, ColorLab Guide to access video guides and documentation, Language Settings to change the interface language, and Account Access to log in or log out of your account. Now let's go back to the Input section and upload our file. ColorLab offers 3 ways to import data for processing. The first one is to import absorbance spectra from any benchtop spectrophotometer. For successful import, it is necessary to select the file type, CSV or Excel, indicate the column delimiter, set the parameters for calculating CLab values. By selecting the relevant supply chain, such as wine, beer, or oil, the software will automatically set the parameters for step, illuminant, and standard observer, according to the reference standard. By clicking on Import, you can select the file to be analyzed. The file must contain the wavelengths in the first column, the absorbance data of the samples in the next columns, the names of the samples on the first line. If they are present, make sure to remove the header and footer. Press Validate Data to verify that the file is correct. Any errors will be highlighted. Set the optical path of the cuvettes and press Calculate to get the CLab values. For each sample, the following values are reported: brightness, L, chroma, C, hue, H, components A and B, and the illuminant standard observer and optical path. Automatically, blank columns are added to enter the date and time of the analysis or sample descriptors. For example, for wine, mix percentage and type of bottle closure. Every time the table is modified, you must click Update Graphs. Finally, the results table can be exported to CSV. The second option is to import data from the Smart Analysis spectrophotometer. Analyses performed with Smart Analysis are automatically synchronized with ColorLab. Select the sessions to analyze and add any descriptors. Each time the table is modified, click Update Graphs. The third and final option is manual data entry. You can create a new table and manually enter CLab values and sample information. Let's go back to the imported data from the Bank spectrophotometer. ColorLab offers several types of graph representation. Polar graph. This view displays CLAB data in LCH format. On the left side, you can see lightness, or L, with values ranging from 0 to 100. On the right, the polar graph shows the hue angle and chroma, which indicates the purity of the color, represented by the distance of each point from the center. Each point on the graph corresponds to a sample in your dataset. You can use the selectors on the right to zoom in or filter specific samples. Below the graph, you'll find a table showing the corresponding numerical values. There, you can choose a descriptor from the menu to highlight specific features of the data. The colors or symbols of the points will change based on the selected descriptor. 2D graph. This graph plots the A and B coefficients on the Cartesian axes. You can adjust the scales on the X and Y axes to better visualize your data. 3D graph. The 3D view maps the samples into the full three-dimensional color space. You can further customize the visualization by adjusting the X, Y, and Z axes. The calculation section groups together functional modules for specific data processing. The time analysis module allows you to monitor the color evolution of samples over time. This function is useful for tracking color changes caused by factors like aging, storage, or treatments applied to the samples. The color difference module allows you to calculate the color variation between samples. Start by selecting a reference sample against which the color difference, delta E, will be calculated. The difference can be displayed using 2D, 3D graphs or an ordered graph. You can highlight specific samples to make them stand out in the graph. Additionally, within the Analysis Over Time module, you can track how the delta E color difference evolves over time. The Color Mix module allows you to simulate mixing two samples and estimate the resulting color. Choose the two samples to mix from the menu. Set the minimum and maximum percentages for the mixture, and specify the step size for the simulation. Press Calculate to generate the results. ColorLab automatically calculates the spectra and CLAB values for each mixture percentage. The estimated color will be shown in polar, 2D, or 3D graphs. If you specify a reference sample, ColorLab will automatically calculate the mixing percentages closest to the desired color. You can also set a delta E threshold to highlight samples that meet the acceptability criteria. To save your working session, simply click the Save icon. Saved sessions will be listed under My Sessions. From here, you can access and edit them anytime. Once you're done, you can log out of your account or close the page directly.